What's up everybody, long time no see. In this video we are going to look at the problems A and B from today's Codeforces Raif round 1. Let's get started. The problem A is called box is full. In this problem we have two things, a box containing food and a rabbit, which will be moving this box from point having coordinates x1 y1 to the second point having coordinates x2 y2, and in 1 second the rabbit can only move this box by 1 unit, and we need to find out the minimum number of seconds this rabbit needs to move the box. Let's see how this problem can be solved. So we have 2 points which are having coordinates x1 y1 and x2 y2. You see, if x1 is equal to x2, in that case the rabbit only needs to move the box by an absolute difference of y1 minus y2. It does not need to shift itself by any unit in any direction. And in second case, if we see y1 is equal to y2, then we only need to move our box in x coordinate. In that case the answer would be absolute difference of x1 minus x2. And if we see the absolute difference of x1 minus x2 as well as the absolute difference of y1 minus y2 is non-zero, that is they both are greater than 0. So in this case a rabbit needs to move the box in both the direction, in x direction as well as y direction. Let's say our first point is located somewhere here, and the second point is located at this point. So first let's say the difference between the x coordinates is diff1, which is this, and the difference between the y coordinates is diff2, which is this. So first of all, our rabbit needs to move this box from point P1 to this point, which is equal to the absolute difference of their x coordinates. But then if you see, our rabbit would be 1 unit away from the box which it is carrying, and the rabbit would be 1 unit away in the direction of its movement. So when the box has reached to this point, our rabbit would be 1 unit away from this point. So, and we need to take our box upwards by diff2 unit. So it needs to be present at this location, which is 1 unit above than the current position of our box. To get to that point, so our rabbit would be moving first of all 1 unit up and then 1 unit left. So it takes 2 more seconds, or there is one more way. Our rabbit can move 1 to the left first and then it can move 1 to the up. So we need to add 2 more seconds just to place our rabbit in the correct direction, and then after moving to that direction, our rabbit would be taking the box from this point to point P2, which it would be taking absolute difference of y1 minus y2. So if these two terms are greater than 0, then the answer would be equal to this, and in these two cases the answer would be equal to this. And if the point P1 and P2 are equal, then the answer would be 0. That's all for this question. Let's see the code now. As I've said, if they are having the same x coordinate, then the answer would be difference of their y coordinates, and if they are having same y coordinates, then the answer would be difference between their x coordinate. In the last case, if we see the absolute difference of x coordinates as well as the y coordinates is greater than 0, then we add 2 to the differences which I had explained. That's all for the problem A. Now let's see the second problem. Problem B is called belted rooms. In a snake exhibition there are n rooms numbered from 0 to n minus 1, and between these rooms between the adjacent rooms as well as the n-1th room in the first room, which is at 0 and n-1 index. We have some edges. Let's say these rooms are nodes and these these conveyor belts are edges. So we have three types of edges in this structure. So what I'm saying is, suppose we have a graph, node are the rooms, and we have edges. The edges can be directed, the edges can be in the one direction, or they can be bidirectional as well. So, and what it says is we have a snake in each of these rooms, and we need to find out in how many of these rooms, if a snake gets out of that particular room, it would be able to get to the same room after traversing some nodes. And yes, they have said that the belt can move in three directions. Either it can move in clockwise direction or anti-clockwise, and in the last case it can be used to move in both direction. We need to find out such rooms from if a snake leaves, it will be able to get to the same node. So if we see, let's say I'm talking about two nodes A and B, and if there is a directed edge only in one direction, that is, if we can move from node A to node B only, then we would be able to get to this node again only if there is a clockwise cycle in our structure of rooms, or graph you can say. Only if there is a clockwise cycle, then only we can reach to the same room again. And in other case, suppose if we are having an edge from B to A and we have left from B, then we can only reach to this B again if we are having an anti-clockwise cycle in our graph. And if you observe, if we are having an either anti-clockwise or just clockwise cycle, then if we are having this cycle, then the answer would be N in this case, because we can start from any node, and as we are having a cycle in our graph, we can start from any node and we would be able to reach to the same node again. So all such rooms can be termed or are of those types which we want to find out. And the cycle can only be of two ways: either the cycle would be in clockwise direction or it would be in anti-clockwise direction. And the edge, which is bidirectional, can be used in both the ways. So first what I did was I tried to find out whether there is a clockwise cycle or not. If there is a clockwise cycle, the answer would be N. If there is an anti-clockwise cycle, if we are not able to find a clockwise cycle, then we check for anti-clockwise cycle. If there is anti-clockwise cycle, then again the answer would be N in that case. And how we can check that? We will start from any node, see if there is a edge from left to right to its adjacent node, which is to the right of it. We move to that node, and even if it is a bidirectional node, then also we move to its adjacent node. And at the end, if we are able to reach to the same node again, then we can say there is a clockwise cycle. So to check for the clockwise cycle, I am using this edge as well as this edge. And to check for the anti-clockwise cycle, I am checking this edge as well as this edge. So using this edge, if I am able to traverse the whole graph, then there is a clockwise cycle, and using these edges, if I am able to traverse the whole graph, then there is an anti-clockwise cycle. In both the cases, answer would be N. Otherwise, if there is no cycle in our graph, then only the nodes which are connected through bidirectional edges would be such nodes which we want to find out, the number of such rooms which we need to find. Because if there is a bidirectional edge between them, then we can move from A to B and then B to A again. So the snake was able to leave from node A and it was able to reach to the same node again. So in all other cases, we just see if there is a bidirectional edge between A and B. I add both these A and B to my set, and I do this for all my edges. Whenever I see a bidirectional edge, I add it to my set, and as I'm maintaining a set, the duplicate values would be neglected. I would only be using them once, and at the end I'm just printing the size of my set, which would be containing all the unique nodes which are connected by bidirectional edges. So yes, let's see the code now. Well, first of all, I'm checking whether there is an anti-clockwise cycle or not. So for anti-clockwise, I would be looking for the edges which are of type this and this. If at any point I see I'm having an edge of this type which is clockwise, then I cannot have an anti-clockwise cycle. I simply break out of the loop. And if I traverse the whole nodes, I traversed all the nodes and I was not able to find such node, then there is an anti-clockwise cycle. I see the cycle is still true, and I print n and get to my next test case, and then I check for the clockwise cycle. If there is a clockwise cycle, I print n. Otherwise, I check for all the bidirectional edges. If it is a bidirectional edge, I add the nodes which are connected by that bidirectional edge, which is I and I plus 1 mod of n, because the last node of our structure, which is at n minus 1, and the first node, which is at 0, can also be connected. At the end, I'm just printing out the size of my set. That's all for this question. I hope you liked it. If you did, please like the video and consider subscribing to our channel if you haven't. I'll see you in the next video. Till then, take care. Happy coding.